Okay, let's talk electrolytic cells. Now, you've got this setup here, and what they're saying is, hey, they want to use the setup to purify copper. What that means is they want to make copper, right? And if you look at the setup, you're like, hang on a second, everything is kind of sitting in one cell. So to me, that suggests this is going to be electrolytic cell. So this is going to be electrolysis. Okay, right, think about what happens during electrolysis. Now, what you're really trying to achieve is, if you're going to purify copper, it's because you actually want to coat something with copper, right? So what you actually want to do is, the final outcome that you want is to coat this guy with copper, specifically copper solid. So if that's the case, then you think, okay, what needs to happen here? So in order for this to happen, if you look on your electrochemical series, in order to produce copper, you need copper ions to undergo reduction, which means that wherever it is that you want to coat stuff, that's got to be your cathode. Always for electrolysis, okay? It's got to be your cathode. So let's think, if that's the case, then C has got to be our anode. Since this is an electrolytic cell, A needs to be our power supply, because we know that this is a non-spontaneous reaction, which means we have to put in energy for this to force this to happen. Okay, so really it's not going to be a voltmeter for A, so let's get rid of A and C. We know that this guy here, the pure copper, is going to be our cathode, which makes C our anode. So really the answer here is B. The last part is just to show you why B is a cation. What you want to happen here is, if this is impure copper, the whole point of that is you want to kind of like get rid of all the other crap, and you just want to pull out the copper from it. And also knowing that you've got copper ions in here, so really you want this. You have this, right? You want that to come over to the cathode. You want it to gain electrons, undergo reduction, so that you can form the copper solid on top of this cathode. Now, what you also want to happen here is the copper that's in here to break down, contribute to the copper 2 plus ions. You know that the copper 2 plus ions, they are cations. They're going to move here. They're going to collect electrons from here, undergo reduction as per this reaction to form copper solid, which is going to form on the outside. That's why the direction of the cation flow is you want the cations to go towards the cathode, gain the electrons to make the copper.